So similarity lesson part 2. More ratios in similar triangles. Theorem number 1 states that in similar triangles, the lengths of the altitudes from the corresponding vertices are in the same ratio as the lengths of the corresponding sides. So in this given example, triangle ABC is said to be similar to triangle DEF. So ABC similar to DEF, and BG is perpendicular AC, meaning to say that that's the altitude, and EH is perpendicular to DF. Again, this is the altitude for triangle DEF. According to the theorem, those segments BG over EH will be equal to the ratios of the corresponding sides. So in this case, I just wrote them all. So BG, so the smaller triangle over the bigger triangle. That's how I'm going to call it. So BG over EH will be equal to AB over DE, and also going to be equal to BC over EF, and will also be equal to AC over DF. Again, because this is similarity, you can actually interchange them for as long as you're consistent. Therefore, if you put EH over BG, or started with the bigger triangle over the smaller, all these will be equal for as long as you also start with the bigger triangle and get the corresponding side of that with the smaller triangle. The next theorem states that in similar triangles, the lengths of bisectors of corresponding angles, which are the angle bisectors, are in the same ratio as the corresponding sides. So in this case, triangle FUN excuse me, is said to be similar to triangle SAM. These two are similar. Excuse me. And NY bisects angle FNU, which means that FNY is equal to YNU. So that's the meaning of bisect. So we go to here and it says that ME also bisects angle SMA, which means that SME is congruent or equal to EMA. So when this happens, according to the theorem, what's happening is the lengths or the ratios of the lengths of the angle bisectors excuse me, will have equal ratios to the corresponding sides. So the way I did it was I started with a bigger triangle. So ME over NY is equal to MA over NU, and is equal to MS over NF, and is equal to SA over FU. Once again, because these are similar triangles, you can actually interchange and start with the smaller, going all the way to the bigger, but make sure that you're consistent when you do that. Okay, this is a continuation. You might need to flip to your next available page. The last theorem for this notes is in similar triangles, the lengths of the medians from the corresponding vertices are in the same ratio as the lengths of the corresponding sides. This only means that in this example, triangle BOX, so BOX is said to be similar to triangle SUN, and so OE is congruent EX, which are equal to EX, which means that that's the midpoint, making BE become your median. And in this case, UY is equal to YN, which again makes SY your median. It connects the vertex to the midpoint of the opposite side. So what happens when you have this are all these. So BE over SY is going to be equal to the ratios of the corresponding sides as well. So again, I started with BE, so I can start with BO over SU equal to BX over Sn equals to Ox over Un. Now, in this particular example, for our last example, I made sure that I put the or. What if I start with my bigger triangle going to my smaller one? Can that happen? And the answer is yes. If I have the median SY over BE, that's going to be equal to SU over BO and is equal to Sn over Bx and is going to be equal to Un over Ox.